This time we're going to slide some boxes across the ground, and these boxes will be attached by a string, but we will pull on them up at an angle. So we will add some sort of angle adjustment to the pulling force. And I think in this case we'll say that there's also going to be friction. So let's say that this is a 10 kilogram box and this one's a 20 kilogram box. And again, let's pull with 50 newtons and a force, but let's make that a 30-degree angle that we are pulling up with. And let's add in some friction. So let's say that there's a force of friction of 5 newtons here on this 20 kilogram box. And let's say that there's a force of friction equal to 2 newtons on this 10 kilogram box. So let's apply all of that and again find the acceleration of the system. Let's find the force of tension right here on this string that connects the box, and again find the normal forces for the 20 and the normal force for the 10 kilogram box. So those are the things we'd like to find. Our process is going to be free body diagram. So let's look at the 20 kilogram box, and we'll look at the 10 kilogram box. The forces on the 20 are going to be the weight, the normal force, force of tension is going to, force of tension, not the normal force, the force of tension is going to pull us forward. And we noted that there's 5 newtons of friction, so that 5 newtons of friction is going to retard or act against the force of tension. In the 10 kilogram box, we also have the weight, and we also have a normal force. We have force of tension pulling back. We also have this 2 Newton frictional force that is retarding, so we're trying to move forward, and the friction ends up slowing us down. And we have this 50 newtons that is at this 30-degree angle. Unfortunately, that's not anything useful for us right now. What we'll notice is that if we end up with a coordinate system, so our step 2 is to pick a coordinate system, x and y, we'll notice that everything is in the coordinate system, x or y here. Everything's in the coordinate system, x or y here, except for this 50 newtons. So what we need to do is we need to decompose that, and we say, let's break that down into an x component and a y component. And so this y component is going to be 50 newtons times the sine of 30 degrees, and this over here is going to be 50 newtons times the cosine of 30 degrees. So now we have everything in the coordinate systems that we want, and we can apply Newton's laws to write down the equations, and we end up with, let's do sum of the forces in the y direction for each box, and then sum of the forces in the x direction. And what we notice is normal force is positive, mg is negative, equals mass times acceleration in y. Here we have normal force is positive, and we have this 50 sine 30 is positive, and the mg is negative, equals mass times acceleration in the y direction. X direction here, we just have force tension minus 5 newtons, mass times acceleration x. I have a lot going on here in x, so I have a 50 cosine 30. I have minus force tension and minus 2 newtons, and then that's going to equal mass times acceleration in the x direction. Again, because nothing is really going on, this thing is not changing its motion in the y direction here. We're just sliding to the right as we pull. That means that these accelerations are going to be 0, and that allows us to solve these guys immediately. The normal force is going to be equal to mg, and in this case, it's going to be equal to 20 times 9.8. So the normal force is going to be 196 newtons for the 20 kilogram box. And over here we end up with normal force is going to equal to mg minus this 50 sine 30. So it's going to equal to 10 times 9.8 and then minus 50 sine 30. Plug in those values, you end up with a 98 minus 25, which is 73 newtons. So it equals normal force. So we've got our two normal forces. The reason those are easy is because we get zero accelerations in the y direction, and we're able to just solve those immediately. Until we use friction coefficients later, we don't really need those normal forces, but we do know how to solve for them. In terms of the force, tension, and the acceleration, I now have here force, tension, acceleration unknown, force, tension, acceleration here unknown, two equations, two unknowns, so that becomes easy to solve. I'll write those equations down and I'll plug in the appropriate masses. So force, tension minus 5 equals 20 AX, and then rewriting this one, I end up with 50 cosine 30 minus force tension minus 2 equals 10 AX. And again, it's a pretty straightforward elimination. Add those equations. 50 cosine 30 minus 7 equals 30 AX. And so now just doing the math, we can solve acceleration in x is going to be equal to, let's see here, cosine of 30 times 50, that's going to be 43.301 minus 7 divided by 30. So divided by 30, we end up with an acceleration of 1.21 meters per second squared. And then again, that's pretty straightforward. Just plug that guy in into that guy, and we can find our force tension. So we end up with force tension equals 20 AX plus 5. Or force tension is equal to 29.2 newtons. Okay. So pretty straightforward. The only thing we needed to be careful with was this coordinate system, this force that was not in the direction of one of our coordinates, so we just broke it down into the x and y coordinates and solved everything